Okay, so we're going to start a new section today, chapter 18 and 19. Okay, I'll give you an outline sheet next time. Don't forget your exam is on Wednesday, starting at 3 to 5. Okay. And you'll also be having quizzes this week in your session upstairs. Okay, it'll be on C13, NMR, and a mass spectroscopy. Okay, and I'll hand out a sheet later on in class that it's a sheet for some extra practice problems that you can do. Okay, but let's get into chapter 18. Okay, chapter 18 covers aldehydes, and ketones. Okay, very important topic here. And what we're going to get introduced to in this chapter and be looking at some later chapters is this group here. Okay, remember that's the carbonyl group that we saw in IR and C13 and so forth. Okay, so in this chapter we're going to get very acquainted with this carbonyl group. Okay, we're going to study the chemistry of it, how it reacts, properties, and so on. It's a critical group to understand, especially in biochemistry, and those of you that want to go off in the medical field. Okay, but before we get into the carbonyl group, what we're going to spend some time doing is naming aldehydes and ketones. Okay, so let's first of all look at how to name aldehydes. Okay, so first of all, what is an aldehyde? Okay, an aldehyde is on the carbonyl where I have at least one hydrogen on the carbonyl. I could have two, but I have at least one hydrogen on the carbonyl. So let's look at some examples. Some aldehydes. So these are just a series of them. We're just adding more and more carbon atoms. Note in each case we have at least one hydrogen on the carbonyl. So how do we name these things? They're very simple to name. Okay, one carbon. Remember, one carbon is methane, but what we do is we drop the E, and we have a new suffix, Al, so we have methanol. Okay, so you see the ending for aldehydes are the first two letters of aldehydes, Al. Okay. I'm willing to bet that you can name the other two. What would be the name of this one? Methanol. What about the last one? Propane. Okay, so pretty easy to name, aren't they? Okay, but be careful what that letter is. If you had an O there, that'd be an alcohol. Okay, so make sure that's an A. Some of these things have some trivial names with them. Methanol is more popularly called formaldehyde. Okay. Probably work with formaldehyde in your biology classes. Does that smell very good? No. Okay. This one here is also called acid aldehyde. Okay, that's one of the properties of aldehydes, is they generally don't have very good smells, okay? As you can smell with formaldehyde, and all these other aldehydes stink too, okay? Formaldehyde is a toxic molecule, so make sure you don't breathe too much of it in the lab, okay? It's best just to put the animal in the hood so you don't breathe the formaldehyde. Okay, so a lot of plastics will give off formaldehyde under high heat. Okay, so you got to be careful with formaldehyde. Okay. Okay. Well, this aldehyde group sometimes is written in a condensed manner, like this, CHO. Okay, so CHO is the same thing as the aldehyde group. Okay, so don't get thrown off if, for example, for propanol, propanol could also be written like that. Okay, so be familiar with the condensed version of the aldehyde group. Okay. So what about an aldehyde that might look something like this? For example, okay, where we have a group on the molecule. Okay. Well, here we would have to start numbering it, wouldn't we? Where the aldehyde group would be 1. And then we number down. So that would give us 3-chlorohexanol. Okay. So we number there. Why didn't we put a number over here, say on propanol? Why didn't I call that 1-propanol? It's on the 1 carbon, isn't it? But it's what? Understood, okay? Because I know it always has to be at the end of the molecule, and it will always be number 1, okay? So there's no need for numbers unless I start having groups down the chain there, okay? Okay, these numbers are sometimes replaced with Greek letters, okay? So the carbon next to the carbonyl, alpha carbon, beta carbon, gamma, delta, and we usually stop there, okay? So sometimes in the old way of naming this, they would call that beta chlorohexanol. Okay, so if you see that old nomenclature, don't let it throw you off there. Okay, and remember we already got introduced to aldehydes in benzene chemistry. Remember the name of that aldehyde? Benzaldehyde. Benzaldehyde. Okay? So, we got introduced a couple of chapters ago. Okay? So, that's all there is to naming aldehydes. Pretty simple, aren't they? Mm-hmm. Okay? well, let's go on to the other one, the ketones. So first off, what are ketones? Okay, well, we still have a carbonyl, but this time, both sides of the carbonyl have a carbon okay? Aldehydes, we had what? At least one hydrogen over there, okay? So let's look at some examples of ketones and see how to name these. Obviously, the most simple ketone would be what? A 3-carbon ketone, right? And then after that, I can start growing the chain. Start putting some CH2s in there. So let's take a look at how to name these things. Okay, so this first ketone is 3 carbons. Remember, 3 carbons is propane. Okay, so what we do with this one is we drop the E. Okay, instead of adding Al, now we add -one for ketone. Okay, so that's the ending for ketone, so we get propanone. Okay, next one, 4 carbons long. Butanone. Okay. Then 5 carbons would be pentanone. Okay. At pentanone, we get something new. Does anybody see what we have to do with pentanone? Are these 2 pentanones?
Number.
Yeah, I need a number now, don't I? Okay, so this would be what? 2 pentanone, and that would be what? 3 pentanone. Okay, so these 2 are isomers. So once I get to isomers, I have to start using a number. Okay. So make a note of it. Starting at pentanone, I have to start using numbers. Okay? So for hexanones, all the hexanones, 2, 3, 4, and so on. Okay. All right. Any questions on these ketone names? Okay. Ketones also have smells with them, okay? And just like aldehydes that have smells, anything that has a strong odor generally tends to be flammable, okay? So ketones, you put a match to it, they won't explode, but they will ignite, okay? A nice flame. Same thing with aldehydes. This ketone here It's also called acetone. Okay, that's the more popular name for it. Big one in the lab. Okay, acetone is the primary ingredient of what? Nail polish remover. Okay, so we'll take the pink off real quick. Okay, and your orange off. Is that orange or red? Okay. We'll take that scarlet off. Okay, so if you get this on your hands, acetone evaporates real quick, so your hand will feel real cold. That's the way sweat works. Okay, bodies were designed for sweat to cool you down. Okay, so let's look at some other ketones. Okay, remember back in benzene chemistry, we looked at the phenones. So what is a phenone? A phenone is where I have at least one side of the carbonyl being a benzene ring. Okay? And I have one carbon on the other side. Okay? Everybody remember the name of this one? Acetophenone. Okay? So you see the word phenone. Everybody remember another phenone we looked at? That one there, what was the name of that?
Benzophenone.
Benzophenone. Okay, so those were the names of the phenones. Well, let's look at something else here. Let's suppose we had this molecule. And we wanted to name this one. Any ideas how to name that one? So on the right track, you just need a little help here. So 2, 4, it's 6 carbons long. So it'd be hexane dione. Okay, so you put di on front of the one. Okay, if you had 3 of them, a trione, and so on. Okay, so there'll be a lot of diones that we encounter. About something like that. What do you think you'd call that? One, 4, again, 1, 4, cyclohexane dione. Okay, 1, 4, cyclohexane dione. Okay, so we'll see a lot of diones as we go through this chapter. Okay. Let's look at another one. Let's suppose we had this molecule. Same problems with naming this molecule.
Has an aldehyde.
Okay, yeah, I got an aldehyde and a ketone. So I gotta make a choice. Do I name it as an aldehyde or do I name it as a ketone? Okay, so it depends which one has priority. Okay, so which one has priority, ketone or the aldehyde? You don't know, but now you do. It is the aldehyde. Okay, so write down the aldehyde has priority over the ketone. Okay, so it's a 4-carbon aldehyde, which would be butanol. Okay, again, I don't need a number where that aldehyde is. But now, what am I going to call this thing, this carbonyl on 3? I got to let the reader know there's a carbonyl. Okay, this is what's called an oxo group. Okay, so a carbonyl that's not part of the parent chain we call the oxo group. So this would be a 3-oxo-butanol. Any questions on that one? Yeah.
What's the oxo group again? Carbonyl
A
then?
carbonyl that's not part of the parent chain. Okay? Or a carbonyl, okay, that is used in the molecule, but there's also an aldehyde group. So I gotta call this an oxo. I'll leave the aldehyde group an aldehyde. Any other questions on it? Okay? You don't see that too often, but you might see one on the exam. Okay, so I think that's it for the naming of aldehydes and ketones. Okay, any other questions on those? Okay, well, let's shift gears then. Start getting into the chemistry. Let's look at how to make aldehydes and ketones. Okay. And there's a few ways to make them. What we're going to do is start with the most popular way. And the most popular way is from alcohols. Alcohols. Okay. We'll use a very popular reagent called PCC. Okay, so let's see what PCC is. Okay. This molecule here, an aromatic ring with a nitrogen there. This is what's called pyridine. Pyridine. Okay. Smells like fish. If you take the pyridine and add a hydrogen here, that makes the nitrogen have a positive charge, and so it starts converting the pyridine into a salt. And pyridine as a salt is called pyridinium. Pyridinium. And anytime I have a salt, I need a counter ion, like sodium chloride, Na plus Cl minus. So what's my minus here? thing here, which is a chlorochromate. And so we have the full name, pyridinium chlorochromate, which is what PCC stands for. Okay. And PCC, remember, those of you that had me for Organic 1, anytime you see a chromium in there, it stands for a strong oxidizing agent. Okay, so PCC is going to be a strong oxidizer. Okay? So this is the structure, but we'll often just abbreviate it PCC for obvious reasons there. So let's see how this thing goes to work. Okay, so if I had an alcohol, something like that, and reacted with PCC. Okay, this is a very simple reaction. You may want to write it down so you don't forget. What PCC does is it converts the alcohol portion to a carbonyl. So we would get butanone there. Okay? So 2-butyl alcohol becomes butanone. Okay? See how it's oxidizing? It's adding what? Making that a double bond. So that's part of the definition of oxidation. Okay? About something like that. Okay? So here, this was a secondary alcohol. Down here, that's a primary alcohol. So again, it's going to convert that to a carbonyl. This time you get the aldehyde, don't you? Because you're dealing with a primary alcohol, which is at the end of a molecule. Okay? So if you're at the end, you get the aldehyde group. Okay. Okay. Same thing for something like that. If I had 2 OHs on here, what's it going to do? Oxidize both of them. Give us that molecule. Okay. So wherever it sees an OH, it's going to oxidize into that. But note they have to be either a primary or a secondary alcohol. It would not work on a tertiary alcohol, would it? Say, well, why not? Well, take a look here. Okay, so there's tertiary. Why wouldn't that work? Well, let's try it. All right. So there we go. And then I'm trying to form that. What's wrong with that? Too many bonds on carbon. We've got 5 bonds. Okay, illegal structure. Okay, let's just put a nice big X around that. Okay, no reaction. So whenever you see a tertiary alcohol, throw it out the window. Okay. Okay. In fact, that looks so ugly, I'm going to erase it. Don't like that up there. Bad. Okay, so that's the primary way of making aldehydes and ketones from these alcohols. Now let's look at some other ways that aren't as popular, but we need to look at them nonetheless. Okay. So next way we'll look at is from alkynes. Okay. Do you remember what alkynes were? Triple bonds. Okay? I see some people putting these reactions on note cards. Excellent idea. Okay. So let's look at a triple bond. Okay, so here's a simple one to start with. And there's two reactions that we can do on this one. Okay, let's look at this one first. Okay, we call this A. So we're going to react this with a mixture of mercury in the 2+ state, sulfuric acid, and water. Okay. So what's the first letter of mercury? What's the first letter of mercury? Okay, it's a simple question. M. M. Okay, it's like some of you forgot that, so I better spell it out. Okay. But mercury, M, stands for also middle. Okay? So what this reaction is going to do, it's going to go to the middle carbon of the triple bond and make that a carbonyl. Okay, so a nice oxidation. Okay, so it makes the middle carbon a carbonyl and adds some hydrogens over here. Okay. So that's one way to react a triple bond. Let's look at the second way. Let's redraw the molecule. Okay. And you have two parts of that triple bond. You might say, well, how can I put the carbonyl on the other carbon of it? Okay? You want to be able to do both. So how can I put the carbonyl over here? Well, obviously, we'll have to use a different reagent. And this is what you use. Explain what that is in a second. And water. Okay. And, or I'm sorry, hydrogen peroxide. And sodium hydroxide. Okay. So hydrogen peroxide is an oxidizer. Okay, so it's going to oxidize this carbon to the carbonyl. So in this case, make the aldehyde. So this compound here, this stands for silyl, which is a silicon, and amyl, which is a 5-carbon isomer branch. Okay, so we abbreviate it SIA. Okay, what you have is a silicon with this 5-carbon isomer branch that's connected to the boron there. Okay. Not critical about this. Just remember this, and you'll be fine. Okay. All right, let's look at one more way to make aldehydes and ketones. And this way is from carboxylic acids. Okay? So remember, carboxylic acids are this functionality here. Okay? What we're going to do in this reaction is a 2-step reaction. First of all, going to react it with RLI, where R is an alkyl group. So this is sometimes called an alkyl lithium. Okay, so R is some alkyl group. And then secondly, react with H3O+, okay, the hydronium ion. Not going to take you through the mechanism. I'm just going to show you the short way to remember the product. Very simple. What happens is the alkyl group replaces the OH group. Write that down. The alkyl group replaces the OH group. Okay? And so we end up forming a ketone of some type. Let's look at an example. Let's, for example, say we had benzoic acid. With this ethyl lithium and H3O+. Okay, you should be able to draw the product here. What would you do?
Replace the OH with the ethyl.
Replace the OH with the ethyl group. Okay. Give you that type of phenone molecule. Okay. Our reactions are going to build up in this chapter and the next. Make sure you're keeping track of these on note cards. I know you're studying for your exam Wednesday, and that's good. At least get these on note cards, so when you do come back and study this stuff, you're set to go. Okay? All right. Any questions on this? Okay, let's hold on before we take a break here.